Look at this very nice problem. Here, for which values of theta, where theta lies in the closed interval 0 pi by 2, the quadratic equation in t, which is t cube minus 3 sin square theta into t plus 2, have repeated roots, that is double roots. We have to find out the values of theta, where theta also lies in the closed interval 0 pi by 2. The polynomial in t, which is t cube minus 3 sin square theta into t plus 2, have repeated roots, that is double roots, that is it has two equal roots. We have to find out the values of theta for which this will happen. Now let's start the solution. Here the polynomial is given as t cube minus 3 sin square theta into t plus 2. This polynomial t cube minus 3 sin square theta into t plus 2 as the polynomial pt. This is the polynomial in t. This is also polynomial in third degree. Highest degree is 3. Here this polynomial has repeated roots, that is double roots. When this polynomial has repeated roots, that is double roots, for which values of theta this polynomial has repeated roots, that is double roots. We have to find out the values of theta. Now we have already known the condition for a polynomial to have its double root, that is repeated roots. To have double roots, its first derivative with respect to the variable equal to 0. At double roots, the derivative, first derivative of the polynomial must be 0. Here we have to find out the values of theta for which this polynomial have double roots, that is repeated roots. Here also for we apply this condition for this function to have its double roots. This condition is derivative of this polynomial, that is dpt dt equal to 0 for repeated roots or double roots. Here roots is twicely repeated. Here the roots of this polynomial is twicely repeated. So we have dp dt equal to 0, ddt of pt equal to 0, that is first derivative of this polynomial is 0, must be 0 for repeated roots, that is double roots. And this equation also give us the repeated roots of this polynomial. This equation gives us the repeated roots, that is double roots of this polynomial. Now at first we differentiation of this polynomial, take differentiation. The first order differentiation of this polynomial is 3t square minus 3 sin square theta into t equal to 0. This is the first order differentiation of this polynomial. So here we get t square equal to into 1 into derivative of t is also 1. This is the first order differentiation of this polynomial. So here we get t square equal to sin square theta, which implies t equal to plus minus sin theta. T equal to sin theta is a double root, or t equal to minus sin theta is also a double root. For t equal to sin theta, pt also 0, because this is a root. T equal to sin theta is a root of t, so at the value of t equal to sin theta, the polynomial is 0, because t equal to sin theta is the root of this polynomial. So pt equal to 0 at t equal to sin theta. So p sin theta equal to 0. P sin theta equal to 0 means sin cube theta, we can put t equal to sin theta in this equation. We get sin cube theta minus 3 sin square theta into sin theta plus 2 equal to 0. That is minus 2 sin cube theta plus 2 equal to 0. That is sin cube theta equal to 1. So sin theta equal to cube root of 1. Here also this equation also 3 roots. Only one root is real, but other 2 roots are unreal, that is imaginary. Only one cube root of 1 is the only real root of this equation, and other 2 roots are imaginary, that is unreal. So this is the root of sin theta equal to 1, and also 1 is equal to sin pi by 2, sin 5 pi by 2, sin 9 pi by 2, and so on. Also minus sin 3 pi by 2 minus sin 7 pi by 2, minus 3 pi by 2, sorry, minus 7 pi by 2. These are. So we have got the value of theta. So here we have got the values of theta as values of theta equal to, so here we have got theta equal to pi by 2, 5 pi by 2, 9 pi by 2, dot minus 3 pi by 2, minus 7 pi by 2, and so on. But among these values, only theta equal to pi by 2 satisfies this inequality, that is 0 less equal to theta less equal to pi by 2. So theta equal to pi by 2 can be only accepted, can be only accepted. So theta equal to pi by 2 is only accepted because theta equal to pi by 2 belongs to the interval 0, closed interval 0 pi by 2. Theta equal to pi by 2 belongs to the closed interval 0 pi by 2. So here only theta equal to pi by 2 is only accepted, only theta equal to pi by 2 is accepted. So here for theta equal to pi by 2, this polynomial has repeated roots, that is double roots. Now for other value, sin theta equal to minus 1, for other value t equal to minus sin theta, for t equal to minus sin theta, the polynomial pt also 0, because t equal to minus sin theta is also a double root of this polynomial, that is root of the polynomial. So at t equal to minus sin theta, pt equal to 0. So p of minus sin theta equal to 0, and p minus sin theta is also, polynomial is this. So minus sin cube theta minus sin theta cube minus 3 sin square theta into minus sin theta plus 2 equal to 0. So minus sin cube theta plus 3 sin cube theta plus 2 equal to 0. So here 2 sin cube theta plus 2 equal to 0, that is sin cube theta equal to minus 1, and also this implies sin theta equal to cube root of minus 1, that is equal to minus 1. Only sin theta equal to minus 1, cube root of minus 1, that is this is the only real root of this equation, and other two roots are also unreal, that is imaginary. Here this equation has 3 roots, only one root, that is cube root of minus 1 is real, and other 2 roots are imaginary, so they are rejected. Only this root is accepted. Sin theta equal to minus 1 is only the real root, only the real root of sin cube theta equal to minus 1. This is also for sin theta equal to minus 1, we get minus 1 is sine of minus pi by 2, sine of minus sine of 3 pi by 2, sine of 7 pi by 2, and so on, and also sine of minus 5 pi by 2, sine of minus 9 pi by 2, and so on. So theta equal to minus pi by 2, 3 pi by 2, 7 pi by 2, minus 5 pi by 2, minus 9 pi by 2, and so on. There are infinite number of roots for theta when sin cube theta equal to minus 1. Among these roots, any root of these roots, among these roots, any root of among these roots, among these infinite roots of theta does not satisfy this inequality, that is 0 less equal to theta less equal to pi by 2. So here any root cannot be accepted. Any root of this of theta, there are infinite number of roots we have got, and among these roots any root cannot be accepted. All roots are rejected because these roots do not satisfy this inequality, that is 0 less equal to theta less equal to pi by 2. So here any root cannot be accepted. So these roots are rejected. These roots are rejected because these do not lie in the closed interval 0 pi by 2. These roots do not lie in the closed interval 0 pi by 2. That is, these roots do not satisfy this inequality. This inequality is 0 less equal to theta less equal to pi by 2. So these all are rejected. These all are rejected. So here we have only got the solution of theta as pi by 2. So here theta equal to pi by 2, the only solution. So theta equal to pi by 2 is the only solution. Is the only solution of theta for which tq minus 3 sin square theta into t plus 2 has repeated roots. Repeated roots. So only theta equal to pi by 2 is the only solution of theta for which this polynomial has repeated roots.